everyone, welcome to 10-Minute Physiology. In today's very short video, we're just going to be talking about total resistance in the lungs. So with that, let's give it a go. So I'd like to start off by first describing to you a very important law that we've seen many times. So let's just say you have an airway here, and in this airway you have two ends. This end of the airway has a certain pressure, which we'll call P1, and the other end has a pressure called P2. Now let's just say that the pressure on side 1 is greater than the side 2. Where will the air flow? Well, the air will flow from the area of higher pressure to the area of lower pressure. So we'll go from side 1 to side 2. So we can describe the amount of airflow by using Ohm's law of hemodynamics, which states that the difference in pressure is equal to the flow times the resistance. So the key point here is that in order for a fluid to flow, whether it be a fluid like water or a fluid like air, you have to have a difference in pressure. If there's no difference in pressure, no net flow will occur. So this is Ohm's law of hemodynamics. It's the pressure gradient that's going to determine the flow. So the important point here that I want to look into is the resistance. So the resistance can be calculated by this equation here. And the most important factor in the resistance is going to be the radius. So the radius is the biggest determining factor of the resistance. And this is because the radius is going to be to the 4th power. So the greater the radius, the lower the resistance. Now, in order to understand how resistance works, we're actually going to bring in some concepts from your college physics class. So let's just say you have two resistors in series. So we have this circuit here and you have these two resistors in series. So one resistor after the other. And let's just say that each of these resistors has a specific resistance. So resistor 1 has a resistance of 4 ohms and resistor 2 has a resistance of 5 ohms. Now we can combine these two resistors together in order to find the equivalent resistance or the aggregate resistance. And the way you do that for resistors in series is by using this equation here. So the equivalent resistance is going to be equal to each individual resistance of all the resistors in series. So when we do that, we see that the equivalent resistance in this case is going to be 9 ohms. So now let's compare this series circuit to a similar circuit, but in this case we're going to have the resistors in parallel. So when we do that, we see something here like this. So let's just say this is resistor 1 with it being 4 ohms and this is resistor 2 being 5 ohms. So what would be the equivalent resistance in this case? Well, you would have to use a completely different equation. And this equation would be the following. So what you would do then is plug in the values, and what you would get is an equivalent resistance of the following. So it's 2.22222. So the main point here is that resistors in parallel have a lower aggregate resistance than resistors in series. And this is why when you compare the aggregate resistance of, let's just say, a bunch of bronchioles that are branched together to the aggregate resistance of the trachea, the aggregate resistance of the bronchioles all aggregated together is going to be lower than the aggregate resistance of the trachea because you have all of these bronchioles branched off together into a parallel circuit. So the total resistance in the lungs. So the resistance in the lungs is mainly going to be determined by two sources. The first source are going to be the airways themselves, which is going to account for 80% of the total resistance. And the other tissues are going to be responsible for 20% of the total resistance. But what is the biggest influence on airway resistance? Well, the main influence on airway resistance is actually going to be lung volume. So the main relationship that what we're going to see here is that as lung volume increases, the airway resistance is going to decrease. So as the lung volume increases, this decreases the amount of airway resistance because it allows the airways to expand more and therefore widen, increase their radius, and therefore decrease the resistance. So that's all I'm going to talk about in this video. I hope to help you understand resistance, Ohm's law, and a little bit about how resistance and lung volume are tied together. Thank you for watching, and I hope to see you next time.